All right. Welcome everyone to the AI-driven document processing webinar. It is great to have you with us again. This is a rescheduled webinar from previous one. I unfortunately got the flu the last time that we were going to do this, so I'm glad you've joined us again for a really interesting topic. I don't know that document processing is like the most hyped thing that is in the AI news recently, but it's certainly driving a huge amount of enterprise value. It's so important for real business use cases, and just really thrilled to be talking with you all and discussing it with you all today. As a reminder, in these webinars, just in terms of question and answer, we will have time at the end of the webinar to answer some of your questions. And you can either go into the chat window within Zoom and just paste your questions into that chat window, or there's also a Q&A panel within Zoom where you can submit your questions. Sharon, who is on and host here, he's going to be monitoring those questions throughout the webinar, and at the end, he'll feed me some of those questions to make sure we can get those discussed and answered as we move along. So make sure, again, submit questions. We want this to be a back and forth. We want there to be discussion along the way. Just for context, I'm Daniel Whitenack. I'm CEO at a company called Prediction Guard. Part of what we do at Prediction Guard is provide some education and leadership in these kind of AI security privacy best practices through things like the Practical AI podcast, but also Midwest AI Summit, other events, teaching occasionally at Purdue University, or involvement with other organizations like ML Commons or others. But our main kind of effort is providing secure, sovereign AI systems for companies operating in regulated industries or that just have security related concerns. So just by way of introductions, that's context. That's where I'm coming from. We're working day to day with companies that are implementing AI workflows, including those that involve document processing, which we're going to talk about today. Before we hop into that topic of document processing, I do want to make sure that you know that we do have some other upcoming webinars that are going to be really interesting. One of our AI engineers who's been working with all sorts of MCP and tool calling things is going to present in February 11th, about MCP and this kind of universal USB-C of the AI world. So definitely don't miss that. This is how you develop feature-rich AI applications these days and tie in external systems. So make sure you register for that. You can register at predictionguard.com/events. Also, there'll be one coming up in March, the following month, related to knowledge assistance and turning data from maybe unstructured sources like a data lake into kind of a semantically searchable knowledge base of content. So please make sure and register for each of those as you're listening along the way today. Just go and go to predictionguard.com/events and register for those other upcoming events. But let's go ahead and get into the topic of today. There's just been a really fascinating series of developments in document processing models over the years, actually reaching back quite a ways into history, or at least the history of AI, as it were. But there's been rapid progress recently. So I do want to just start by giving you context and a little bit of, I guess, historic context of how these technologies have developed, so you can have that foundational mental model for the different kinds of models that are involved in document processing, the advantages, disadvantages of those, how they might be applied in your context, etc. So first off, I'm going to develop this kind of table as we go through these different models, from LLMs to OCR, document structure, language vision models. Most people, just by way of kind of starting this discussion, are now familiar with LLMs. We've talked about those in different webinars. These are models that predict future text values or next text values from previous text values. In other words, they complete a prompt. That's called autoregressive, and these models are easy to prompt, but in terms of document processing, they really don't do this document processing for you. Now, you could go into your Word document, you could go into your PDF, and obviously a lot of people have and do copy paste stuff out of your document into an LLM or a chat interface or something like that, and then process that information from there. So that's certainly the way that you would do it with an LLM. And I'm just starting with that context as a baseline because most people have done that. They've got a Word document emailed to them over email and they copy paste stuff out. But here we want to transition now from talking about that LLM to models that are actually purpose built for taking in documents or images in certain cases and actually recreating the content of those documents such that you can create automations off of those, or you can integrate that document processing into RAG related pipelines and that sort of thing. So the first of these models, which actually dates back to at least the 1980s, there's certain of this technology prior to that, but this is really where I guess AI models or neural networks started being used for this purpose. There's a series of technologies called OCR, optical character recognition. And here's an example from Bell Labs from back in the day where this optical character recognition was trying to pick out text in a document, in this case, a handwritten document. And really, these OCR technologies still operate in a somewhat similar way to what they did back then. Obviously, the models are more powerful. But if you want to think of this sort of optical character recognition model, which again is still widely used, it's still used in combination with other models. It's used in AI workflows. What happens is you get a document, which is maybe a scan of a document or a PDF that's flat or something like that. And that document includes some type of text with some type of font, et cetera, which might not be readable by a computer right off the bat. In other words, it doesn't have embedded text characters. And so what you do is you take that document in, and with an OCR model, what happens is you treat kind of that as an image. And first you try to identify the bounding boxes or the regions within that document that contain text characters. This is why this character word is used in the OCR acronym. So you take that text, you find those bounding boxes within the text, and then you actually split out the image into a bunch of kind of smaller cropped images or regions. And for each of those cropped regions, then the model, what it predicts is the probability that that region contains one of many characters that are within the kind of vocabulary of characters of the model. And so as you might expect, this works well in certain cases, does not work well in other cases. And if we were to kind of summarize some of that information, an OCR model, maybe you're using Tesseract or something like that, which is widely used. This is a computer vision model, often using kind of convolutional neural networks, et cetera. And the job of that model is to classify pixels or regions of pixels into characters. There's some really good things about this. It's really fast. It's more deterministic than at least some generative models that we have now. Obviously, there's statistics involved. And it's really good in the case where you have kind of good, clean documents that have those characters in them. However, if you notice kind of in this picture, I really kind of lose any context. As soon as I separate out these regions within my document, I lose any sort of context for the structure within that document and where those kind of characters fit into the document. So really good in a lot of cases. Good if you have kind of clean scans or clean documents. Good if there's maybe not as much of that structure and you're just looking for this chain of characters. However, moving on from this, now we want to think about the scenario where, well, let's not lose the context of document structure. Obviously, documents can be very complex. They can have tables within them, they can have formulas, they can have multi-column setups, they can have little text boxes, all sorts of things, headings, titles, etc. How do we then go from an OCR type of system to something that's a little bit more robust, in particular as related to document structure or layout? So, this is where document structure or layout parsing models kind of started to be introduced not that long ago. The kind of first very robust ones kind of started coming out around 2019 and on. And what happens with these is you use some parsing backend, like a PDF parser or a document parser, to pull in the data to kind of deserialize some file, like a PDF or document. And then you use a specially trained model. So this model is not an LLM. It's not a just generic model. It is very specifically trained for a specific task, and that is to take in a document and output this kind of representation on the right. So this kind of representation on the right really defines the structure of that document, and that's why we call these models document structure or layout parsing models. And an example of one of these that's very widely used is called docling. Docling is actually a whole kind of toolkit of things. We could talk about that here in a second. But the idea is that you would take in a document and use one of these document processing models or document structure models like docling to then output the structure associated with that input document. Now, one note here is that this outputs document structure, which is great because if you remember from the OCR side, we lost all context about document structure. However, it does not output text, right? And so actually what you have to do if you want both the structure and the text is then layer on these two things together. So take that document structure layout model, get that structure, and then look at the regions and the metadata about the information within the document, and then combine that with an OCR or even a vision model, which we'll talk about here in a second, to actually then extract the text within those regions. Sometimes, of course, also like in the case of a Word document or a PDF document, if you select that region, there may be embedded text within the document format itself, so you might not need to OCR it in that case. In other cases where you have a scan or something like that, maybe you do need to apply OCR within that document structure. So examples of these document structure or layout models are things, for example, like docling, layout, LM, table former. Actually, as I mentioned, docling, which was originally released by IBM, I believe, is actually more of like a toolkit. If you're looking at the docling repository on GitHub, it actually includes kind of a pipeline of different processing. And so you can actually use table former, I think, with docling. And so some of these things get mixed together with the jargon. And then there are docling specific models that are released, for example, on Hugging Face, which are more of this document structure or layout type of model. And so just in terms of summary of this particular type of model, really what we're talking about here is a model that reconstructs the structure of a document in terms of the sections, tables, objects, figures, etc. And so that structure is preserved, which is a great piece of this. This is used very widely in RAG pipelines. I'll show that a little bit here in a second. But this keeps that structure. It creates you can create nice output kind of markdown from your document, which is really useful in the generative AI context for things like RAG pipelines. The maybe one disadvantage here is that you still need kind of an OCR or vision model to do that text extraction to get a fully end-to-end document structure processing model. And so this isn't kind of an all-in-one model that does everything for you. Okay. The last one that I want to really mention because it is quite widely used as well, and actually now is integrated more and more into kind of the chat assistants that we're using day by day, is what's called a language vision model, or a vision language model, sometimes referred to as an LVM or VLM. And what happens here, you can really think about this as a similar workflow to what you do in your chat assistant. You might take a screenshot of a document or have a page of a document and just paste it right into the chat and give a prompt like, hey, I need to, output this table in text format or give me this cell or something like that. Well, what's happening under the hood with these language vision models is actually you're taking an image on one side. So it's actually something that processes images, not documents. So even if you're putting in a document, it might get converted to images or images of the pages. Um, and that image then is passed through a vision encoder. The prompt is passed through a text encoder. All of this means is like the individual inputs are of different modalities, right? You have an image and you have text. Each of those is then represented in numbers, or encoded. That's what encoding means. You take those things, you encode them separately because they are of two different modes, two different types of data, and then you merge those together into a single input or embedding or embedded representation that then goes into the rest of the model. And that rest of the model then, at least in the case of language vision models, outputs similar to what a large language model would output, which is next token probabilities. In other words, you give the prompt, right? And your prompt is actually a multimodal combination of both an image and text in this case. And then you output next tokens, or this is why the output streams, right? Similar to an LLM. And so it is actually quite expensive because for every token that's output, you're rerunning the model because again, it's auto-regressive. It predicts off of what came before. So you output one word, then you rerun the language vision model, output the next word or subword, rerun the language vision model, output the next, and that's how these models operate. And so the really kind of nice thing here is that they're very interactive. They kind of reason over both of these kind of text and image type of data. Really good often for kind of visual question answer, summarization, putting things into different formats. However, in terms of the exact recreation of model or sorry, of the document content, right? It's not always the best because as we know with any generative model, they hallucinate. If you have low quality document or image, low quality screenshot, that could be very limited in terms of how that's reconstructed by the language vision model. And it's very slow and expensive, like I say, because it operates in this iterative way rather than kind of a one shot model. So just in summary, if you want to have kind of this mental picture of these different kinds of models, you have the LLM, which takes in a bunch of text, which is encoded as tokens, and then outputs the probability of the next token. So that's our typical LLM. The OCR model or optical character recognition model takes in an image and then outputs character probabilities within that image. The document structure or layout model, something like a docling, takes in a document and then outputs the kind of structured representation, often in like JSON or XML or something, the structure, the representation of the structure of that document. And then you have the language vision model, which takes in an image and text tokens and then outputs next token probabilities. So that's kind of the different types of these models. And hopefully this table here gives you kind of a summary also of when and where these might be useful, and even how they could be combined one with another, like docling with an OCR model or docling with a vision model, for example. Okay, moving on, I want to talk just a little bit about now you know about this evolution of document processing models, the different kinds of these models. Let's talk about where they show up in end-to-end workflows. And I just want to give a couple real-world examples of how these might show up. I've already talked verbally about some of those, like in chat interface or others, but I want to show also some kind of real-world examples of where these might show up, and some of the things that we've seen. So the first of these ways that this might show up is in something like a knowledge assistant, a retrieval augmented generation knowledge assistant. In this type of system, and I know I've talked about this in various other webinars and podcasts, but in this type of system, which is extremely widely used now, you take your documents, you parse those, and so you need to have a document parsing model, right? You parse those into chunks. You then embed those in a vector database, which allows for this semantic searching. If you want to know more about this semantic layer, join us in our March webinar to learn more about that. But you put those into your vector database, and then as you get a user query in, you're able to pull the relevant context from your vector database or your knowledge base, and then embed that into a RAG prompt to the language model. Obviously, if you're processing these documents, you might have PDFs, you might have scans, you might have Word documents. This is one of the primary uses of document processing models, AI-driven document processing, is actually to, in a batch way, support this RAG workflow when you're loading in all of your documents into a vector database. And so when you're using any tool that you're connecting your knowledge into, and your knowledge is represented in documents, you have to use one of these models, whether it's OCR, docling, a vision model, etc., to process these documents and then be able to process them into chunks and embeddings throughout the pipeline and get them into the vector database. So I want to show a little bit of that here. This is our Agent Studio builder. And I just want to show a couple places where this shows up. We have ways to create agents within this agent builder that operates in our secure AI systems. And so if I, for example, just do a new chat and I have an agent here that talks about AI security. That agent is actually connected to a knowledge base. If I go down here, it's connected to a knowledge base. And so I've actually created a knowledge base of AI security privacy information. And you can see I've uploaded a bunch of files. I can actually, turn these files on or off. Those have knowledge in them that I've already parsed. However, I can also, as I curate this knowledge base, and this would be true for any system like this where you're curating knowledge, I could actually go in and then add a new document, right? And as I add that, you can see that's uploading. In the background, what's happening is I'm using one of these models, in particular, this sort of document structure processing model, to really get the structure of that document, and then extract the text with either an OCR or a vision model. And then that model is now uploaded. I can enable that model and actually see how this then operates the full RAG pipeline here, by going in and seeing, oh, if I search all of my documents, right, and say my search is what is a prompt injection, right? Submit that. That matches to some things in this document and these individual chunks, right? You can see this is talking about those safeguardings for prompt injections was matched semantically. This text is text that is in my vector database that was parsed out through one of these document structure processing models. And actually, the cleaner this data is, the more it maps to kind of markdown representation, the better it's going to be for use in this knowledge base, which is important for the performance of the agent. So I can turn those on, and now when I go to the chat and like, what is a prompt injection? Um, that's going to search those documents and then use those kind of to actually answer this. So it actually used that PDF that I parsed, right? Now, additionally, I can go in here in most kind of AI systems and upload a file, right? And I could upload that here, and that's going to just put it in the context of this chat individually. But that processing of this file um, was done with that document processing model here. I think I was talking about this data extraction, data entry when the Zoom cut out. What I was describing here was really related to taking documents and automating some SOP or process or play that a human would normally execute. So this would be, oh, I'm emailed this document, this manufacturing process, or I'm emailed this table. I actually want to take that document, send it through a document processing model, extract the document structure and text, maybe combine that with some data schema fields or prompting, and then push it into a database or an external API. So here, what happens is I use this document processing model to output that text, and then I enrich that with some of the context about the system that I'm wanting to push it into. And to give an example of this, one that I'm aware of, which I saw a good friend, Ramin, who's been on the podcast with us recently, actually, with Chris and I on the Practical AI podcast. iBase-T, which is this manufacturing MES, they have what's called MES software. So they have manufacturing process software in the aerospace industry, and they actually have a process that works just like this that they built, which is really interesting. It takes in PDFs, which include kind of complicated figures and tables, et cetera, which represent a manufacturing process. They then drag that into their system called Scan AI, which processes that PDF in a private, secure environment, often in an air-gapped environment, but using an AI model that's in that context. And then they actually push then the information into their Solumina system. So, in my understanding from what they've kind of shared about this product, this was a highly manual process before that took even days, and now they're able to cut that down even to minutes or seconds through this work on the document extraction processing model. So these are the two I think that are the primary use cases for these document models, is either in the context of that RAG or in the context of these kind of data extraction or data entry type of models. Now, before we open it up to questions here, I do want to just give a few kind of key considerations related to accuracy, security, and compliance when it comes to, hey, I'm about to put a bunch of documents into an AI system. There's obviously some things that could come up around accuracy, security, and compliance, because often a company's most valuable data is housed in documents in some sort of data store that they have. So just in terms of the accuracy side of things, I wanted to give you this kind of breakdown, which Sharon will be sharing these slides at the end of our time together. So don't feel like you need to rush to write this down. But I thought this would be a good reference for you to have, where you could really understand, based on the accuracy you need and the type of data that you have, which of these models is going to perform best in terms of document processing. LLMs, although you can copy paste stuff in, they don't really kind of, as I mentioned, preserve this document structure or reduce any errors from like an existing OCR. OCRs are good for that kind of clean scan, but they do break on complicated structures like tables or multi-columns. The document structure models obviously are great at what they're named for, document structure, but they're always going to be limited by the way that you extract that data after you get the document structure, which could be from an OCR model or it could be from a language vision model. Language vision models then are really good at more of the, I guess, the understanding or visual question answer extraction portion of what you might want to do with a document. But they're not going to be able to often reproduce the exact kind of structure of a document. So if you're looking at something to get to preserve the best structure of your document and recreate it, it's not usually going to be a language vision model or a vision language model. On the security side, there's a couple of things that I want to highlight that you all can keep in mind. The first of those is indirect prompt injection or data poisoning. This happens because the documents that you are sent or that are in your system could themselves contain malicious inputs or harmful data that you wouldn't want embedded in things going into your model. So, for example, if you have an agent that reads your emails, right? A malicious actor could send you an email with an attachment, and that attachment could contain a bunch of text. And within that text, maybe they include a prompt injection or some malicious instructions that are hidden because it's whited out text or something you can't see visually with your human eyes, right? But it is there and it would be parsed by one of these models. And so when you push it through a document processing model, that data will be there in your email. That could then be combined with your prompt and directly go into a model, or it could poison, quote unquote, your RAG system because if you're processing that document into a RAG system, that will then be around forever and always in your RAG system and be able to be pulled into some answer that's given to your users, right? So this is one security thing. The other security compliance piece that I want to call out is more related to sensitive data exposure, unauthorized disclosure. It's very tempting when you have an AI agent or tool to say, oh, I just want to connect all my SharePoint, or I want to connect all my Salesforce data, or I want to connect all my database data. Well, obviously, all of these systems own all of our data, right? There's PII in there. If you're in the medical space, maybe there's PHI, there's proprietary data. And often, and I would say most frequently, the governance of these systems is not strictly enforced. And sometimes you don't know where everything is in your SharePoint, for example. And so just connecting those things wholesale to your AI agent or tool is not necessarily a good idea. And so what really needs to happen here is a little bit more curation and thought put into the data sources that you put in, because that's going to directly influence your AI output, and you could leak either sensitive data or proprietary data to your AI outputs. I'm not going to read every word here, but again, we're going to share the slides associated with this webinar here at the end. And I just wanted to provide kind of a security compliance checklist for the people on the call to make sure that you know, hey, checkbox 1, checkbox 2, we're protecting ourselves in a reasonable way against these sorts of issues when it comes to document processing. Some of these things, like number one, it has to do with maybe how you're injecting parsed documents into the prompts to your models. But other things can be kind of globally managed in terms of compliance. So in terms of indirect prompt injection, you always want to have that prompt injection type of safeguard checking for those things on any input to your model, including not just the prompt that the user gives, but the context that comes in from your documents. And we very often see people with Prediction Guard enabling our prompt injection safeguard in a way that monitors that last mile of the context that goes to an LLM. So if you have control of the full stack, you can actually analyze all of the data that's going into the model, and that allows you to check for both these direct and indirect prompt injections. You want to have a system to log and monitor the retrieval and context that's going into agents. In our Agent Studio piece, we do that through the logging there. But regardless of what RAG system you're using, you want to make sure that you're able to track that, especially if there is an incident of some kind. Versioning your RAG data is always a good idea. Monitoring for kind of abnormal content that might go into that. In terms of the sensitive data disclosure piece, you can pair the input to your AI model or the input to your RAG data with a kind of PII redaction or some sort of sensitive data redaction where you're replacing, masking, filtering out PII, PHI, or proprietary information. And then, of course, you always want to make sure that you are grounding and monitoring your system for grounded answers, at least if you're expecting this to be operating in maybe high impact scenarios, especially in regulated industries. You want to make sure that your AI model is giving an output that's grounded in the truth and not just in its own kind of hallucination, which is where kind of factuality or factual consistency checking models are really important. So just in conclusion, would love anyone to reach out to us. Happy to hop on a call, whether that's to give more of a demo of some of the things that we've seen or to just, be a sounding board in your process as you strategize about your own AI systems. As a reminder, please go to predictionguard.com/events, register for those upcoming webinars. Keep up to date with Chris and I on the Practical AI podcast. And then there's a couple other links here, including the OWASP Gen AI project, which has been really formative to the way we approach things and also to this presentation. Yeah, as a reminder, these are the upcoming events. And I'm gonna go ahead and yeah, check for some of these questions. So some of the questions Sharon's feeding me. Um, does the document structure data contain the content in the output too, or is it just for the structure? So those document structure models, like a docling model or a layout table former or something like that, those just output the structure. Now, if the regions within that structure include embedded text, like in a Word document or a PDF, you might be able to extract that immediately. Otherwise, you have to combine that document structure model with an OCR model to get the extracted text. How do you evaluate accuracy for tables and numeric fields where small errors are unacceptable? Yeah, this is really, I think, where the language vision model sometimes fails, because if you have a screenshot of a table or something like that, maybe the text is small or complicated, then that might fail, and you might, for example, miss a minus sign, which is really important, right? Or a decimal point, which is really important. Part of that just gets to the cleanliness of the data coming in, which sometimes you have control over, sometimes you don't have control over. One way to deal with the accuracy of that is to actually use a couple different modeling techniques. For example, use the docling or OCR approach to get that raw data and then validate it with a separate modeling technique like a vision model and just ask some visual question answer against that to validate. So always, I guess that would be kind of more of a cross-referencing to flag potential errors. There are some models that have been released recently, like DeepSeek-OCR and some others that actually work much better on very small or complicated scripts. And so that would also be a choice to look into. How do you handle auditability when documents change over time in a RAG pipeline? Great question. So I think number one is you always want to be versioning your vector database. Your vector database drives the whole behavior of your RAG system. And so as you're adding documents, you should be able to actually roll back to previous versions of your vector database, especially if you suspect that there's been poisoning or the accuracy has dropped. And what we often recommend is that you develop your own kind of suite of tests that you can run against your RAG system, such that when you update your vector database or your RAG system, you could actually back test those questions to see if there's been regression. And then how do teams measure ROI for document AI beyond just headcount reduction? So I think that there's a couple angles here around ROI. Obviously, there's the uh, kind of, you could say, well, if it took me 2 days previously to process this document, and now with a human, and now I can do it in 10 seconds, maybe that was all of that human's job. Obviously, there will be an impact job-wise from this sort of implementation, and that's going to be so. I don't want to not recognize that. Um, in a lot of cases, though, this sort of data entry work, at least in the way that we've observed it, is either not happening because they don't have human capacity to do it, or they can't do enough of it, right? They can't process enough of those documents in the right amount of time. And so it might just be about making those humans more effective in their job or providing that capacity that you didn't have before. Um, the other thing is if you are processing documents and you have a way, as we were talking before, to cross-reference or validate the output of those documents, you could better utilize your limited human review time on the harder documents that maybe fail your validation versus the ones that can be just automated in that sense. Also, I think humans can be then, if they're given access to these types of models or pipelines, they can actually spend more time doing things that AI models are not capable of doing. Like, once you've aggregated all of this information out of these documents, actually making logical choices, developing strategy, you know, doing actual product development work that's unrelated to these. So there's a lot of kind of loaded in that question, and that could probably spend a week talking about that. But those are some initial thoughts. I think that those were. One more question: when does RAG stop being sufficient and require fine-tuning or task-specific models? So I would say in 99.9% of cases, customers do not need to fine tune or create their own task specific model. Even in very domain specific cases where you're dealing with domain specific data, it's really just not necessary in most cases. I think the cases where it is necessary are either one of two places. One where your data is different enough from what a general purpose model has seen that it justifies this. And it has to be very different. I would say, like, for example, working with low resource languages that have never been in a training data set for a language model, right? That's a case for fine tuning. The other case is where you need very high throughput. So a larger model is going to be slower. And if you're, for example, processing things off of a manufacturing line that's operating at a certain speed, that needs to happen at very, very high throughput. And so in that case, that might be justified because you could train a smaller model that would be faster. So I see that's all the questions that came in. I want to thank everyone again for taking time to join us today. Sorry about the little mid-show glitch there, but we got all the information out. Reminder again, register for those upcoming events, and we'll see you on the next webinar.